8th grade math, test 17, study guide, problem number 1. We have to find a range that contains that expression. And we have a radicand that needs to be simplified first. So the number inside the square root is called a radicand. We've got to simplify that. So if I go 23 plus 7 minus 4, that equals 26. So I'm going to estimate the value of rad 26. Well, I look at the two perfect squares that surround 26. 5 times 5 is 25, and 6 times 6 is 36. That means rad 26 is in between 5 and 6. If we're going to find the range, I see that it's rad 26 is closer to rad 25, so it's closer to 5. So the only answer that could possibly work is A. It's somewhere in between 5 and 5.2. Number 2, we're going to simplify the first expression they give us first. So I'm going to go inside the parentheses. This is not the only way to do it, but I think it's the easiest way. Go inside the parentheses and copy the base and add those two exponents. 2 plus 6 is 8. Now I'm going to take a power to a power. That's when we multiply the exponents. And then if you guys remember, negative exponent means you have to flip it. So 2 to the negative 16th means 1 over 2 to the positive 16th. And that's simplified. Now I need to look at the expressions to see which of those is equivalent to that. Expression 1, I have a power times a power. Copy the base and add the exponents. 2 plus negative 18 is negative 16. That's the same. Number 2, I have a division problem, but I'm dividing powers with the same base. They both have 2's, right? So I copy the 2, and I go top, or negative 3 minus 13. When I do the rule for subtraction in teams, I get 2 to the negative 16th. That's also the same. So now we're going to look at expression 3. And expression 3, we see we have both. We have multiplying powers with the same base and dividing powers with the same base. So I recommend doing the multiplying part first. So 2 to the second times 2 to the negative third, I copy the base and add. 2 plus negative 3 is negative 1. Then I just copy the bottom over. And now I do the top and the bottom. So do the top first, then do the top and the bottom. And like we said before, dividing powers, copy the base, subtract the two exponents. That's the same also. And number 4, the fourth one, expression 4, is 2 to the 16th. Well, 2 to the 16th is not the same as 2 to the negative 16th. So the answer for this one was expressions 1, 2, and 3 are equivalent to the given expression. Number 3, we're going to multiply these two numbers that are in scientific notation. So I multiply the coefficients first. I go 7 times 4, which is 28, and then 10 to the 14th times 10 to the 5th. I copy the base and add the exponents. But this is not in scientific notation yet. I have to move this decimal one time to the right. So that's that lesson where we did 3 arrows. Remember that lesson? So we rewrite 28. 28 is the same as 2.8 times 10, right? 2.8 times 10 is 28. And then I just copy 10 to the 19th down there. So I put a 1 there because I moved it one time, and I put a positive 1 because 28 is bigger than 1. 0.28 would be 10 to the negative first, right? So I just combine my 10s again. 10 times 10 to the 19th is 10 to the 20th. Copy the base, add the exponents. Number 4, it says that magic word about. That's our friend. So if we're going to divide these two numbers here, and we know we're going to divide because when they say how many times more means, well, how many times more we're going to divide those two. So because they say about, I get around. 5.099 is basically 5, and 9.9 whatever is the same as 10. Now when I divide 5 divided by 10, a common mistake is think that's 2. Remember, it has to go in and out. So that's not 2, that's 0.5. Alright, 5 tenths is a half, 0.5 is a half. So 10 to the 21st power divided by 10 to the 19th, I copy the 10, I go 21 minus 19. That's the shortcut for dividing those two. Just copy the base, subtract the exponent. Now I'm going to rewrite this in decimal or standard notation, so I'm going to move the decimal 2 times. Since it's positive 2, I'll move it in a direction that makes it bigger. So if I move it once, it clears the 5. I got to add a 0 to move it one more time. So it's about 50 times more, or 50 times larger. Number 5 says the value, we're going to find the value of D. In other words, we're going to solve this equation here. So before I solve it, I'm going to set it up. I'm going to write my elevators right and do my rule for subtraction. And then I'm supposed to distribute and combine like terms, but I can't distribute because there's nothing to distribute, so I just combine like terms. I see that the d's are like terms and the constants are like terms. Negative 4 plus 7 is 3. They're both d's. 5 plus negative 8 is negative 3. And now I solve. I work farthest away from the variable. I do the inverse operation of a negative 3, which is to add 3. That makes that go away. 3d left on the left. 27 plus 3 is 30 on the right. Divide both sides by 3, and I see that the answer of the solution is 10. 10 will make this equation true. 10 is the solution. Number 6, we have a problem that says find the value of x. In other words, we're solving this. It's another way of saying solving. So I have a subtraction problem in there, so I can do the rule for subtraction to make less mistakes. So I do the rule for subtraction. I draw 2 sticks right there. Then I distribute negative 1/2. Negative 1/2 times 4x is like saying what's half of 4x? Well, the half of 4x is 2, but negative times positive is negative 2x. Negative times negative is positive, and half of 6 is 3. And then I just copy the rest. So I distributed there. Now I combine like terms. Negative 2x plus 5x is 3x. Notice I'm not doing inverse operations because I don't do that until I'm done simplifying. I got to simplify first. While I'm simplifying, I don't do inverse operations. Now that I'm done simplifying, now I'll do inverse operations. So now when it's a positive 3, I'll do the opposite or subtract 3 from both sides. And I get a 0 over here. Make sure you write the 0. Don't leave it blank because that confuses many of you. So write your 0, then divide by 3, and 0 divided by anything is just 0. So the solution is 0. I need to plug in a 0 up there to make this true. Number 7 says we're going to pick all the equations with no solution. Well, if it has no solution, that means it has the same coefficient, different constants after you simplify. So we have to simplify first. This first equation up here, when you see a negative outside parentheses, you have to distribute that negative. The left side simplified, the right side, I'm going to do the rule for subtraction first before I distribute that negative. When I distribute the negative, negative times 2x, or the opposite of 2x, is negative 2x. Negative times negative 5, or the opposite of negative 5, is positive 5. So I distributed. I see that I have the same thing on both sides. Same coefficient, same constant. I don't have to keep solving this to say the number of solutions. I can see it. Because when I have same constant, same coefficient, that's infinitely many solutions. That's the same thing on both sides. Now, I ran out of space here, so let's go to the next page. So let's test equation 2 right here. So equation 2 says some subtraction parts, right? So I'll do the rule for subtraction. I'll draw 2 sticks right here, 1, 2, and 2 sticks right here, 1, 2. Remember, a subtraction outside parentheses where there's 2 terms in there is like distributing a negative 1. That's the same as taking the opposite of everything. So I do my rule for subtraction here. Now I distribute. 8 times 2x is 16x. 8 times 1 is 8. Copy this. Copy this. Negative 1 times 3 is negative 3. Negative 1 times negative x is positive x. So I distributed. Now I combine like terms. Again, remember, on this step we're not doing inverse operations. So when I see a negative 4, I don't add 4 to 8. I just use the negative 4. So 16x, 8 plus negative 4 is 4. Over here, 15x plus 1x is 16x, and copy the rest. I've simplified it. Now I can answer this question because I just need to know how many solutions it has. This one has the same coefficients and different constants. That means no solution. This is one of our answers, but we have to test the rest. So I'm going to test equation 3 now to see if this has no solution. So, like the others, I'm going to simplify. I need to distribute over here. I can do the rule for subtraction. After I distribute, I combine like terms. 50 plus negative 10 is 40. Over here, negative 2x and 3x is just x. And I see that I have different, after I simplified, that is, after you simplify, if you have different coefficients at all, different coefficients, different numbers in front of x's, right? That's always one solution. Even if I had x's over here and no x's over there, that's different coefficients, right? They're not the exact same thing. So that's always one answer. So I don't pick that one because this question is asking us which one has no solution, and that one has one solution. So that's not it. All right, and number 4 says, here's a long equation. And I hope you're pausing these videos and doing these off to the side yourself and just checking your answers with me, not just listening to me, because it won't stick if you just listen. You have to do it with me. So we're going to go ahead and do the rule for subtraction here, rule for subtraction here, and rule for subtraction here. Now we're going to distribute. Negative 2x, negative 2 times x is negative 2x. Negative 2 times negative 4 is 8. Now we combine like terms. So I combine the 8 and the 10. Over here, I combine 2x and negative 1x and negative 3x. Well, if you did teams with 2, negative 1, negative 3, that would give you a negative 2, right? Now both sides are simplified. I see I have the same coefficients, different constants. That's no solution. So the two that had no solutions were equations 2 and 4. All right, problem number 8. The question says, and a lot of you are confused with this because you're trying to match the graph with one of these tables or equations, and that's a mistake. You have to read the directions. The directions saying which relations located under the graph have the same slope. So none of these are going to be the exact same as the graph, so don't try to match it up that way. That's the mistake that you're making. Instead, find the slope for everything and see which ones, in this case, have the same as the graph. So we have to find the slope for the graph first. If I look at the graph and I take 2 points on the lattices, I have to rise up 1 and over 4. So if I rise up 1 and over 4, and I see that it has a positive upward hill slope as opposed to a negative, right? This would be a negative. This would be a positive. So I have a positive 1/4 slope. So now I test all the other ones. Relation 1 is a table, so I'll take 2 points from the table. 4 is on the table and 0,3 is on the table. So I go y minus y over x minus x, and I get a slope of 1/4. That's the same. Relation 1 has the same slope. Relation 2 is a table also, and that table has the points 7, 7, and 0, 1. So those of you that know the shortcut, because this is proportional, take the shortcut, but most people, some people still don't get that. So we'll just do the same thing we did before. I go y minus y over x minus x, and I get a slope of 1. So that doesn't have the same slope. Relation 3 is an equation in slope-intercept form, and I can see the slope just by looking at the coefficient. That's not 1/4, that's negative 6. And relation 4 is, it says a line contains these 2 points, so it's just like the tables, but instead of picking the 2 points, I just use the 2 points they give me. Again, I subtract my 2y, subtract my 2x's, and I get a slope of 1/4. So the relations that have the same slope as the graph are relations 1 and relations 4, because they both have a slope of 1/4, and the graph has a slope of 1/4. So that's how you answer that question. Number 9 says, which ordered pairs below are solutions for this equation? So the first ordered pair they gave us is negative 2, 5. I have to plug those numbers into this equation and see if it makes the equation true. So let's do that. This is x and this is y. So I put the 5 where the y goes and the negative 2 where the x goes. And that's what that looks like. Now when you multiply fractions, you make everything fraction. Do your factor trees and cross out your ones. Negative 1/2 times negative 2 is positive 1. And 1 plus 4 is 5. So pair 1 is a solution to that. Pair 1 works, okay, because it makes it true. 5 equals 5. Now let's go to pair 2. Okay, pair 2, or ordered pair number 2, is 0, 4. So I plug that in. 1/2 times 0 times anything is 0, right? And that's true. So pair 2 worked also. Pair 2 works also. Ordered pair number 3 is 0, 9. When I plug that in, you should get this. And multiply that, that equals 0. That's not true, so don't pick any answers that has pair 3 as a solution. Let's see, ordered pair number 4 is 2, 5. When I plug that into the equation, I get that. Negative 1/2 times 2 is negative 1. That doesn't work. So the only pairs that did work were pairs 1 and 2. Ordered pairs 1 and 2 are solutions to that equation. Now, which of the equations here are linear? Well, A, I see has regular x, regular y. That's a line. B looks like regular x and regular y, but if I tried to isolate this, the x would actually be on the bottom of a fraction. So when you got x and y right next to each other as opposed to separated with the plus or minus, that's not linear even though it looks like it, so don't fall for that one. C can't be linear because it's absolute value of y. It's got to be regular y, nothing fancy. And D has y squared, so that won't be a line either. So the only one that's a line is A. Number 11. We have a graph, and they want us to write the equation. Now, if I look at the graph, I see that the line hits the y-axis at 3, so that's my B. If I look at the line and I take 2 points on the lattices, I go, it looks like I'm going up 1, right? But if I look at the numbers, it's from 3 to 6, so I'm actually rising 3. And then I go all the way over, it looks like I'm going over 2, but actually I see that each little tick mark is only worth half. So if I go all the way over to this, that's 1. So I go up 3 over 1. So it's got a slope of 3, a y-intercept of 3. My equation is 3x plus 3. Number 12 says select whether the statement is true always, sometimes, or never. If two lines have different slopes, two lines that have different slopes intersect at exactly 1 point. So is that always true, sometimes true, or never true? Well, if they have different slopes, they're always going to intersect one time. That's always true. 13. We're going to select a statement that correctly describes the solution to this system. So we're going to start to solve this system and then see what happens and then choose our answer. So let's start to solve this. We already have one of the variables isolated, so I substitute this into the other one where that variable goes using parentheses. And just like before, we're solving equations by doing our rule for subtraction. So I did add the opposite, drew 2 sticks. Let's go up here now. Then I distributed. 4 times 2x is negative 8x, and distribute the 4 to the negative 3. 4 times negative 3 is negative 12. That's where the negative 12 came from. So I just distributed down here, distributed the 4. Combine like terms. Negative 4x and 8x is positive 4x. Now I solve. Add 12 to both sides, divide by 4, and I see that negative 1 is my x value. So there's a solution. Nothing weird happened here, right? My x's didn't cancel out. So it's not infinitely many or no solution. There's one solution. But there's 2 options. Okay? So already I know it has to be C, but just in case, just to make sure I didn't make a mistake, I plug negative 1 into one of the equations. I solve for y, and I see that y is negative 5. So I know for sure now that C has to be the answer for this one. Okay, so be careful because on the test it can be infinitely many, no solution, it could be the other point. So just solve them both, see what happens. That's how you answer that question. Number 14. 14 is a similar idea. Okay, has to do with systems, but it gives us one equation in the system, and it says which of those other equations given, which of the 4, make a solution that has a system. A system that has a solution with infinitely many solutions. Now, what you can do is you can solve 4 different systems, but that's a lot of work. So the shortcut here is to put all of the equations in slope-intercept form, because if it has infinitely many solutions and you put them in slope-intercept form, it'll be the same equation. So that's the shortest way to do this. Let's take a shortcut here. So infinitely many solutions means once they're both in slope-intercept form, you have the same equation. So I'm going to take the given point, not the A, B, C, D, the one they gave us in the problem, the first one here, right there, and I'm going to put that in slope-intercept form. That means isolate the y. So you see that x is positive, so I subtract x from both sides. Don't try to combine these two because they're not like terms. Instead, just put them next to each other. The x is negative because I subtracted it, and the 10 was positive. A common mistake is I see some of you put a negative there because this one's negative. Well, that one's positive, so keep the same sign. Now I divide everything by negative 2. A common mistake here is people forget to divide this or this by negative 2. When you divide everything. The ones cross out here now. Negative x over negative 2 is negative over negative is positive. X over 2 is 1/2 x. We learned that in class one day. I don't know if you remember that, but relearn it right now. X over 2 is 1/2 x. X over 3 is 1/3 x. X over 4 is 1/4 x. Okay? So I divide these two, I get negative 5 right there. Okay? So that's my original equation. So I want to see which of these 4 are the same as y equals 1/2 x minus 5. So I'm going to take the other ones. Let's start with A, and we're going to do the same thing. Let's isolate the variable. I have negative x, so I add x to both sides. That equals positive 2y equals positive x plus 8. So since I added it this time, it's positive. Okay. I continue, divide everything by 2. Remember, x over 2 is 1/2. Okay. But 8 divided by 2 is 4. So that's not the same as this, so don't choose that one. B, I'm going to subtract x from both sides. Now I divide everything by negative 4. Negative over negative is positive. X over 4th is 1/4 x. But when I divide 5 by negative 4, that's negative 5 over 4, right? That's not the same as negative 5. So B didn't work. Let's try C now. I subtract x from both sides. Now I divide by 4. I get a negative slope, and 5 over, that didn't work either. And D, hopefully D works. So I add x to both sides. Remember, we do the x's first, right? Then we divide by the coefficient, and I get 1/2 x minus 5. So pause the video. Again, do this work and make sure you get this. This is why this one will make infinitely many solutions with a given problem, because you get the same equation. Number 15 says, a gym charges $30 per month. That's 30x. X stands for the number of months. Gym B charges $15 per month, so per tells me the 15 goes next to the X. And 105 initiation. Initiation means a one-time deal, right? Just to get in. So I don't put that next to the X. So when I want to know how many months are they equal to each other, I set them equal to each other. And I solve. Subtract 15x from both sides, divide by 15, and I see that after 7 months these two will equal each other, or they will cost the same at that point. Alright, so that's 15. Number 16, a student solved the system. So this is what the student did. They solved the system, right? And this is what they got. And in the test, you don't have to actually do this work. On the test, they said the student solved the system correctly, and these were the last two steps. So all you have to do is, when you see that, what does that mean? Well, when the x's cross out, and you have something true, that's infinitely many solutions. That means if I try to put these both in slope-intercept form, they're going to be the same line, right? 17. Okay, 17. Let's look at the test for 17. 17, we want to say which of these are functions. So the first one, example 1, is an equation, okay? And as long as it's an equation that doesn't have something like y squared, equations like that are going to be functions automatically, okay? Now, so example 1 is a function. Example 2 is a table. Oh, and the reason it's y squared is because, and I believe I showed you this in class, is if you plug 1x in, it's possible to get out 2y's, and that makes it not a function. So you're really just looking for like a y squared or possibly absolute value of y. Other than that, all the equations you see are going to be functions. Okay, in 8th grade. So example 2 here, this table right here, none of my x's repeat, so that's a function. So examples 1 and 2 are functions already. Example 3, I see 2 x's repeat, negative 21, negative 21. Remember, the y's don't matter, right? The y's can repeat, but the x's can't. So example 3 is not a function. And example 4 fails the vertical line test. You see this vertical part here? If I draw a vertical line, it's going to hit that more than once, right? Because it's vertical itself. So the answer for that one was A. So question number 18, we have a table. We have to give the equation for this table. Okay, so for this table here, what's nice about this table is that our domain here, our x's, are in order. And if they say linear function, sweet. If they're in order like that, I can actually see the slope by looking at the table. I see that this goes up by 3 every time. So I know my slope is 3. And if that doesn't make sense, you do what we've done all year. Take 2 points, subtract your y's over, subtract your x's. You're going to get 3 that way also. So I see it goes up 3 every time, so that I know my slope has to be 3. And I see that when x is 0, y is 2, that has to be my y-intercept right there, right? And again, I taught you how to do that algebraically if that doesn't make sense, but take the shortcuts. Y equals 3x plus 2 is the answer. So number 18, looks like we have a graph here. We've got to write the equation for this. I see the line hits the y-axis at positive 1. So that means my slope, my y-intercept has to be 1. My b is 1. Now my slope I can see is negative because it's going downhill. So I take 2 points. Here's 1, here's another. I have to go down 1 over 2. That's a slope of negative 1/2. That means my equation is that. And for 20, they gave us an equation. We have to figure out which one of these matches it. What's tricky about this is that they don't tell us exactly the numbers. But this is actually one of the easier problems because there's no work to do. If you look and see your y-intercept is positive 1 right here because it says plus 1, just look and see which of these graphs intersect at 1. This one intersects the y-axis at a negative number, so it can't be D. This one, it looks like it's about 1. This one's higher than 1, and this one's higher than 1, so I already know the answer. Okay, but let's say I put another one kind of in the same area. Okay, so let's say that there was other options other than the y-intercept. So let's take a look at the slope. A slope of negative 3 has to be negative. Well, only equations A and B have negative slopes, so it has to be A or B just based on that alone. Now, another way you would know is slopes that have fractions are kind of shallow. Slopes that have whole numbers are kind of steep. So I know for that reason also it has to be B. I would not take the time to graph this and then get my answer. Although that would work, I would just do it the way I just showed you because it's faster. Alright, I hope that helped you guys out.